is being able to go through and identify which formula we need to use in a particular application. So our directions here are to write down the correct formula you need to solve the problem and then solve the problem. Round all answer to 2 decimal places. So we have 11,000 is invested at 6.5% interest compounded continuously. How much will there be in the account after 8 years? So we have a set amount that's being invested, and it's compound. So that means we're looking at one of these 4 formulas here. Now they said compounded continuously, so we don't have an end value. That eliminates this formula, and that formula. And that only leaves us this first formula, which is our formula for compound interest when it's compounded continuously. So we're going to write down that formula. So that's the formula we're using. And now we're going to go ahead and use it. So I'm going to replace replace P by 11,000. E. We got to write our interest as a decimal, so the 6.5 becomes 0.065. And then our time, T, is 8 years. And then we're going to get out our calculator and make that computation. So here we're going to go ahead and we're going to take 11,000. Oops. Let me try it again. 11,000. Second, ln. That gives us our E. Then we're going to type in 0.065 parentheses 8. Hit enter. And if we round that off, that'll be $18,502.30. Let's try number 2. Miguel gets a 5-year loan for $25,340 at 8.2%. What is his monthly payment? So 5-year loan. Loan is the key there. We're going to be using the fixed installment loan. That's the formula we're going to be using. And again, the key word here in this one is loan. So our formula is PMT equals P times R over N, all divided by 1 minus 1 plus R over N raised to negative NT. We're doing this monthly, so that tells us that N here is going to be 12. Our rate is 8.25%, 8.2%, so that'd be 0.082 for our rate. And then P, of course, is the 25,340. So let's go ahead and plug those numbers in. Our N here, this is monthly, so N's got to be 12. And then T here is, this is a 5-year loan. So T here is going to be 5. And so now we're just going to punch this in our calculator. So we're going to put in that fraction key, 25,340, parentheses, fraction key, 0.082 over 12, close the parentheses. And down here we're going to have parentheses 1 minus parentheses 1 plus fraction key 0.082 over 12, close parentheses, caret key, negative sign next to the enter key, 12, parentheses 5. Hit your right arrow and then close off the parentheses. So rounding that, that would be $516.23. Alright, let's try problem number 3. If Shara invests $350 at the end of each quarter in an account that pays 7.5% compounded quarterly, how much will she have in the account at the end of 10 years? So this problem is, we've got a periodic deposit. So anytime we got a periodic deposit, we've got to use our annuity formulas. So remember, the annuity formulas are up here. We've got how much is going in per month, or sorry, in this case per quarter. So we're using this first formula here. So let's go ahead and write it down. And so we're going to now go and plug in the numbers. So in this problem, our payment here is $350. And let's see, R, 7.4%, so that becomes 0.074. We said this is compounded quarterly, so N is 4. And we're doing this for, looks like 10 years. Alright, so now it's just punching into our calculator. Trying to get the lighting better here. So I'm going to do my fraction key, 350, parentheses, parentheses, 1 plus fraction key 0.074, and do a down arrow, that's over 4, close parentheses. We're going to do our caret key for parentheses 10. Close it off. Hit our right arrow, -1. Close it off. Down arrow, parentheses, fraction key, 0.074 over 4. Then close off the parentheses. And then we go and hit enter. And that looks like about $20,466.70. Alright, so let's turn the page. Let's look at number 4. How much money does Leroy need to put into an account today at 6.9% compound monthly so he'll have $56,000 in the account at the end of 10 years? Alright, so he's putting money in an account today, so it's a fixed amount he's putting in. He's not adding anything to it, so we know that it eliminates the annuity formulas, so forget about those. Looking at the compound interest, now we want to know what he needs to put in today. What's going to be at present? So that forces us to use this formula here. P equals A times 1 plus R over N raised to negative NT. So if we look at our problem, we got 56,000, that's our A value. Our R value, 6.9%, so that'd be 0.069. And we said this is compounded monthly. So that means N is 12. And we're doing this for, looks like we're doing it for 10 years. And now, so go ahead and put that on your calculator. So we'll have 56,000, 1 plus our fraction key, 0.069 over 12, hit the right arrow, parentheses, caret key, make sure you use the negative sign next to the enter key, 12 times 10. And that gives us $28,143.82. So all these problems we're doing the same thing. We're first picking out the formula, and then once we're determining the formula, we are then doing the problem. Let's look at number 5. 1,500 is borrowed at 35% simple interest. How much has to be paid back at the end of 3 months? Well, the key word there is simple interest. So we're playing with this problem here. That's the formula we need to use because we want to know the amount that has to be paid back. So we have A equals P times 1 plus RT. P is $1,500. R. It's going to be 0.35 time. Well, this is how months. It needs to be years, so we're going to divide by 12. And then we're going to go and do the computation. So we're going to have 1,500. 1 plus 0.35 times fraction key 3 over 12. Enter. And so that gives us $1,631.25. So $1,631.25 would be the amount to pay back. Now let's look at number 6. One account pays 7.2% interest compound monthly, and the second account pays 7.25% compound semi-annually. Which one is the better investment? So we're talking about compound interest. Now, we notice we're missing a lot of information. We don't have the time. We don't have the principal. All we have is the interest rate and the compounding. So that's going to eliminate these two formulas as well as this one. This is the only one that we can apply here because all we have is the rate and the compoundings. So our formula we want to use here and we'll have to use it twice is 1 plus r over n raised to the n minus 1. And again, it's got to be the formula by default because it's the one that we have enough information to plug into. Alright, so let's look at the monthly investment. Interest rate here is 7.2%, so we'll write that as 0.072. And n here, it's compounded monthly, so n is 12. For the semi-annually, we're using the same formula, but our interest rate is 7.25%. And let me correct that. And it's semi-annually, so that means interest is compounded twice a year. So let's go ahead and put each of these in the calculator. So we're going to have parentheses 1 plus fraction key 0.072, oops, 2, down arrow 12, right arrow, close it off, caret key 12, and then we're going to subtract 1. And then we're going to multiply that by 100 to change that into a percent. So that's about 7.44%. And looking for the better investment, so we're looking for the one that has the higher return. So let's try the second one. We're going to have 1 plus fraction key 0.0725 over 2, close parentheses, caret key 2, and then subtract 1. So that'd be 0.07381 blah 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 blah. So 7.38%. That tells us that the monthly investment is better.